That's one of the topics we can talk about. What is AI? It's a buzzword.
Is it? Is it though? Is it actually?
Well, what is the definition of AI? When does algorithm end and AI start? Is all the algorithms AI?
Are they?
Are they? I'm asking you.
I guess if it's something simple like if else, then.
But if it's 100 if else put together,
it's kind of like a rule engine.
Self-driving cars also have a lot of rule engines that they work and drive with. A lot of Starship is rule engine. Is it AI?
But they probably have something else outside of those rule engines.
That's what we can talk about in the podcast.
So today we will talk about AI product management and probably about AI products. What are they? Is it a buzzword? Is it not? What are even AI products and AI product managers? And today here with us, Liisi. Thank you, Liisi, for coming.
There is way more uncertainty. It is a research topic, meaning that usually we are going into trying to solve something, but we don't know whether it's even solvable. We have two topics with building AI products. Those are the companies who we talked about. They are like building the products themselves. That core is AI. And like without it, it's like there is no product. If you're not doing that, then you're mostly doing automation with AI. You're automating something.
Most important question, how to actually become an AI PM?
I think like overall, first is
at the beginning, we talked about Tesla. Is it AI product or is it not? Is it?
Yeah.
Now I actually...
Well, that's an interesting question. That's what I have been asking, like, what is AI? For me, it's a little bit, has been buzzwordy the past years, due to, LLM's growth, basically, that we have gotten way better. Because of that, those AI services or AI products are way more, reachable to regular consumers. And therefore, we kind of use this AI buzzword. But a lot of the times, if we talk about AI, we talk about in reality something that is, or if you go to definition, it's basically something that is human-like, or we expect something that is human-like that can maybe think or do something like we do. But we have had quite a lot of systems also before the LLMs came that also can do the same things. We have had self-driving cars to some extent. We have had those self-driving package robots, Starship robots, quite industry, quite some time. We have had a lot of automation overall inside manufacturing, basically replacing human work. So is it like AI or not? So that's where I'm in that boat that in reality, AI or machine learning and data science and all the algorithms or all the other methods behind it, those are tools that we can use to create the products. But AI has more buzzwordy kind of feeling to it. But in reality, kind of we have been creating those intelligence systems for quite some time. That maybe they haven't just been so consumer facing before.
Like, what's the difference then between the AI product manager and a simple traditional product manager? I don't know how to call that product manager.
We can have what we have usually had done is software engineering products building. I think everybody's familiar with that. So I think like there are some differences that come when we manage AI products overall. So first is there might be some issues with the kind of AI part. Then it's never 100% right. It is doing mistakes. And one of the things that you know always is that it will have failures. So you need to figure out how you what do you do with them? For example, even if you have self-driving car, even if it's 99.999% of the times detecting all the passenger or like all the pedestrians correctly, there will be always in some cases that it will not. What do you do with it? So basically, what I'm talking about is that we can be a lot of the times correct, but there is some small percentage we are wrong. And sometimes even it's okay to be 70% of the times wrong. Or like not wrong, 70 times right and 30% times maybe wrong. So maybe in some machine learning use cases, it might be okay. For example, if you kind of recommend maybe some products to people, with using machine learning, using these topics, then you basically, if you're a little bit wrong, maybe that's kind of okay. You can have a bigger error margin there, and basically people would not be too unhappy. But again, if you go into really critical roles about maybe self-driving cars, that really some bad things can happen, everything, then first of all, we need to be really, really sure that we are correct. But secondly, we need to also have fallbacks. And I think one of the big fallbacks we see today in our cars, I think if you buy a newer car, most of the newer cars, it doesn't have to be the self-driving car even, you will have this almost safe self-driving mode. So it tracks the road and everything like that. It's kind of already pretty nice. But one of the safeguards that is there is you are always responsible. You always have to hold the wheel. So even if it's self-driving, you as a driver are always responsible. In reality, the car is not taking the responsibility away from you. So this could be one of the design methods, maybe, for example, for almost self-driving cars. You have a car that is pretty good from functionality side, but you basically are still keeping the user accountable. You don't, as a company, want to take responsibility of it. And the second is what we can do in a lot of the cases when we are not sure on the answers or think that they might be wrong. We can do most of the things automatically, but maybe when we are a little bit more unsure, we're sending still those things to humans to validate, to take a look. Or we are giving this responsibility for the users themselves, that we are not taking the decision all the time. So these are the methods that could be used, or putting multiple different algorithms together to reduce, or like algorithms and machine learning models to reduce the mistakes that you have, so that you kind of design around all of the problems. But I think this is one of the biggest kind of changes when you start building software engineering products and machine learning products. Is in software engineering products, you know that you have, for example, a UI flow or API flow, and you know basically always that if you send the data, you get something back, or there might be error, but then you know what you do. But when building AI products, you never know how many errors you will have. You measure them. The amount of errors that happen might change over time. That's the tricky thing, that it might be that today you build a product and it works wonderfully, and afterwards in a year we have a data drift and it's not working anymore so well. So if you take the same example for data drift for LLMs, it could be that we have today's news, that it's searching for what's the latest news and what Trump is today talking about tariffs. And then in reality, if we use the same model in year of time or 6 months of time, it hasn't been trained in between. It's not up to date. It's giving you the wrong answers already. So we have data drift. It's starting to give you wrong answers. Can you rely on this chatbot now? You cannot rely on it anymore because Trump has changed the tariffs 100 times. So that's, for example, like something maybe that relates to you also, Nikolai, that you use every day, that you need to take into account that what data has been trained for.
It reminded me of not exactly the data training part, but the part about fallback mechanism. It reminded me of Amazon had this store, like walk in, walk out, where you don't need to pay. You just walk in and they somehow recognize you. And then people heard that Amazon was checking every single order with outsourced from India or something like this. And people were like, oh, this is the AI. But it seems to be some product manager came up with this fallback mechanism to make sure that everything works well.
Yeah, but then that's an interesting question in a sense that I think this example, like from consumer perspective or the customer perspective, should they care whether it's Indian or whether it's an algorithm? In a sense that the product, the shop itself works exactly the same way. It's a matter of the cost, and maybe speed or something, how quickly they can run off from the shop. Basically what solution you choose, in a sense that from you as a user should not care. Of course, it's nice and sexy if it's AI, but in reality, there are a lot of the times we also hid away this kind of how in reality everything works in the background. We try to not talk about it, maybe because it's not so nice and not so cool. But we can still label it AI a lot of the times. But it could be like some rules. It could be some really simple logic. But if it looks nice, that's the main thing in reality we're solving. So that's maybe coming to also to this why to use AI, where to use AI. Then I think, like mentioned before, and the first, AI is a tool. It's a tool that we as creators of the products could use. But it doesn't mean we have to use it. It might not be the right solution. The right solution might be hiring in the Amazon shop 100 Indian guys and paying for them, because that's maybe cheaper and higher quality than achieving this machine that does everything for you. And you could test the concepts way quicker already. You could do the shop done, like whether people would even go. Building those models would take you, I don't know, a year or two maybe. Depends how far we are, how complex the problem is. So I think a lot of the times it's, let's first start with problem and product and what do we want to build? And then come back to, hey, maybe AI is the good solution to solve some of the things. And I think, it's kind of this is the classical product maybe mindset, that we start with a problem and then solution should come later.
Mm-hmm. Yeah, just want to say, it sounds like classical product management. Nothing too fancy. And but if we still try to think about more AI product managers, what is the scope of work? In the sense, like, I was thinking, there's a data science, there's probably ML engineer or someone who understands how the model works. Like, what is the purpose of AI product manager then? Because it sounds like start with a problem, come up with a solution. Okay, it seems like AI model, ML model, whatever model seems to be a good fit here. Go to engineer and they will figure it out. Mm-hmm. Why do we need to separate it into a separate AI product manager?
Yeah, I think like a lot of the cases, and this is where another maybe difference comes from with AI product management overall, is that you have different teams. So if classically we work with software engineering team, then now we have machine learning engineers or data scientists, however we would like to call them. They are also sometimes called different. It depends on company. But basically, I think like overall everything is a teamwork. So in a sense, I can from product side figure out the problems. Of course, I have ideas how to solve it, how to think about it. Being in the role of knowing some of the AI topics, I know maybe here or there where to plug in AI, where it makes sense, where it doesn't, already ahead. And I might already know ahead some of the topics that when we start building AI products, whether we can or can even build them. So this is the knowledge that I have in my side. So maybe not bringing up these solutions in the places that do not make sense. I can also go into suggesting some solutions, but I of course expect the team also to heavily focus or help to figure out the solution part. But one of the maybe topics that come also in line to figure out whether we should use AI or not should use AI is again like what happens with the mistakes, like we talked about first. Then it's if we are trying, we can choose always whether we buy AI products or services or whether we build our own. So buying is okay, that's easier. You just buy something in a sense from Amazon, from Google, from OpenAI, or use something free source, you just plug it in, it's done. But if you want to start building now something on your own internally, that's another challenge. The question comes in mind, which is, where do you get the data for the training? So that's why not all the companies are building LLMs today. Where do they get the data? They would need to scrape it from the internet and books and everything like that, everything that the big companies have done and built for us. But in some cases, you need to build your solutions in-house because there is nobody's selling that service. And this brings, like I mentioned, another complexity on data. You need to figure out how you get the training data, how you label the training data. Then you need to find the people who label the training data, how accurately they label the training data, how quickly they label the training data. So do they have the knowledge to label the training data? What should be the right answers for this model? Because now if you start really going into building those things, somebody needs to tell what are the kind of right answers and what are the wrong answers. This is where we go into the topics of how you evaluate the models. You need to kind of, as a product manager also, go into in-depth on figuring out how you can evaluate them. What is the right answers? What is the wrong answers? I think the simple topic I have in a sense figured. We can think about taxis, for example. We are the Bolt world also. Is that, for example, let's see, we want to, from image, it's easier for humans to think about images. So you have images, you need to mark whether it's a taxi or not. Okay, basically have this challenge. Doing it in New York, pretty easy. Everything is yellow if it's taxi. Cool. Doing it in UK, also kind of easy. I think everything like black is definitely taxi. But I think there might be something else also. But now you look at where we are operating at Bolt, how in Tallinn, for example, how you then figure out whether something is taxi or not taxi. Well, if there's Bolt written on it, okay, maybe there is taxi, but there is a lot of Bolts that are not written Bolt on them. Are they then taxis? So this comes to play now. You need to really understand, like, what I want this intelligent machine in the future to do. And need to go into these details and those questions. So you as a product manager need to analyze it. Also, with the help of the engineers, of course, if they start thinking also probably some edge cases. So we need to figure those out. But interesting topic. For example, here that you need to really know ahead what is the kind of right answer you're assuming for.
It kind of makes sense. Like now that you talked about Bolt, I kind of want to ask about Veriff and ask about what are the differences. Because I talked to smart people and they said that maybe we can think about AI products as there's a AI product like an OpenAI, where it's like simply like purely model. Then there's a AI as a core for the product, like for example, Veriff. I think they quoted you that if you take out the AI out of this product, then this product stops existing. And then the third one is kind of like Bolt. The core business is taxi, but AI is a nice extra addition, like for example, chatbot, maybe optimizing some processes, matchmaking, etc., etc. Any thoughts on this? What is the difference?
Well, definitely, like they are a little bit different, and they kind of this AI knowledge density is different. So if you are inside a company who is like OpenAI, or who is building basically some other tools that other companies can use for creating some services for their customers. So usually you are then the kind of your service is to building those machine learning tools only. Then of course you are way more focused on the metrics. There's a lot of probably those metrics that we talked about, there's probably a lot of more hands-on only work with kind of creating the better models for different kind of use cases for different customers. So yeah, of course we have those companies. Then we have, like I mentioned, there are some companies whose really core functionality becomes the AI functionality, that they have something else. They will probably survive also kind of without the AI. I think Veriff has also humans who do verifications. But the question is that the AI is so big part of the company already. This is what makes the whole or everything run. It makes the company profitable. It makes sense that the costs are down. It kind of is. This is the rolling thing there, and it is, like you mentioned, really big part of the company. And then we have Bolt, who operates in a lot of the places. There are AI pieces, machine learning pieces, but they are not the core piece of the business overall. So there are also, Bolt is really big, so there are a lot of different aspects in the company. But yeah, regarding how it's different, like I think it is the mindset difference in a sense, a little bit in the all those different types. So if you are really in a company who provides the services themselves, everybody, usually the product managers themselves, really understand concepts about AI, how machine learning, how you build them, how you work around them, the data topics that I talked about, the legal topics that I haven't talked about yet. They are the basics there basically. And when you are now maybe in the very size company, yeah, we talk about it a lot. We had really a lot of people, if you look at the company size, working on those problems. We tracked a lot of those AI machine learning metrics themselves. And they were the kind of core metrics also to the company at some point. But there is still a lot of, maybe, I assume, compared to the first one, a lot of kind of explaining you need to do of why we can do some things, why we cannot do some things. So a lot of education up to the management about what's possible, what's not. And I think this is the difference. And now coming to the bot, I think again, we do machine learning. We maybe kind of, compared to the companies, we buy more than maybe build our own. It could be also that, in a sense that if you are in the middle one, then you probably need to build way more if you look at how many models versus how many you can build by but in Bolt or classical kind of company who uses just this as a tool, you can probably buy in lot. Maybe building it in-house is not so much kind of supported. You don't have maybe the data creators, annotators in-house. In Veriff, we had annotators in-house who annotated data for the training, for example. So a little bit the mechanisms and the teams that support you are different. So right now we are way more lightweight from maybe the support teams that kind of create support this machine learning kind of development overall in the systems and the processes around that.
Basically, what I got for myself is that scope of work for AI product manager, outside of what normal standard software engineering product manager will do, is they come up with fallback mechanisms, or how do we deal with mistakes kind of things.
Yes, I think it's like designing around it is the main thing. How to design around it.
How to they come up with how to design around the mistakes. They have a say in buy versus build. Model, should we buy or build? They have a say in training and labeling. They come up, I think first they come up with an idea what is right and wrong answer, what is right and wrong behavior. And then they kind of come up with training, labeling, what kind of data we use, what kind of data we don't. on what
I
data
think
to train?
that's like a lot of the times what data we use. I think it goes also to engineers and the engineering side, what to use, what makes sense. But one of the big things is how you get the data, and I think product manager plays a big role on also helping to figure out how we could get the data that we need. So making sure that we kind of get it.
And one more point you mentioned is legal. Kind of 5 points. Could you bring an example of maybe some products that you worked on, maybe some features that you worked on?
Well, I think like I have been in a lot of the cases part of all those fives, in a sense that how to get them and how figuring those out. From Veriff times, I can bring also up one problem, how to solve it, how to scope it. It's really to again maybe understanding whether documents are right. Are they correct? Are they fake? Are they not? Are they modified? Like how to fix this problem. That you know that you have this problem, you know that or you have quality problems maybe there, then how do you start looking into it? First is getting the really the scope small, really getting the understanding what is the core root problem. Like somebody could be changing their signature, their photo, as everything like that. Like how do you start solving it? There's so many things that could go wrong or could indicate that it's a problem. So a lot of the like overall this product management is about getting all the statistics in, figuring out those statistics. Is also how do you get those statistics, whether somebody marks those somehow manually, labels them, or you can get them somehow more automatically. Then figuring out the sub problems of that problem. Maybe having one big AI that solves this problem doesn't work. Maybe it makes sense to have smaller AIs that solve that problem. So that's, for example, one of the things we did there is really you try to narrow the scope down to a smaller, really small thing that you can solve. Then you narrow the scope down into that. Then you figure out, again, how you get the data, how you label it, what is the correct answer, what is the not correct answer. So, and this is a tricky piece. I'm not an expert on fake documents. So if I talked to you about before the taxi example of like, look at the picture and see if there's taxi. Well, that I can do. But if we talk about really specific things, like these fake documents, or we talk about like we need you to, what is it? Some medicine, basically models or something like that. The product managers are not doctors themselves. They do not know like from image, whether there's something wrong with the heart, for example, or not.
Mm.
So we need to rely still on some other people to maybe create the data for us. So this is a good example where I might kind of define the overall problem as specifically as I can, but to some extent, my own knowledge is not also so good. And I need then somebody else to give me the expertise or lend me the expertise. But at the same time, we had the 5 problems now. We needed to figure out what goes wrong. So again, what could go wrong here is that we find that some document, for example, is fake, but is not fake. And we could have that we think that some document is not fake, but they are fake. So it covered the 2 different mistakes that you can do. So it's like false positives and false negatives in right? If you go into confusion matrix. And we need to figure out what do we do there. There could be options that you, if the mistakes are too really small, you ignore one of those mistakes. You just map them to some answer. It could be that you ask person to maybe retry. Maybe next time you know better. Maybe it's not. It's just a mistake, outlier. You could a lot of times rely on humans for humans to trying to look at some of the examples. So you need to again design the process so that the amount of the amount of basically the mistakes that you have go down, and also that you do not overwhelm the whole system and make it kind of pointless. And then, we have also the legislation and data kind of privacy problems that are coming up. And I think from product side, you being in an AI role need to really understand also kind of the GDPR and the basics of the data protection overall, because unfortunately from product side, if you are building the products, we are in a world where data is really protected. So you need to figure out where you can use the data. Another thing is also where those models could be used also. And like in some cases, people can opt out on automatic processing now with the AI Act also coming more strongly. So you need to basically, again, design around it, trying to figure around it. Of course, from the product side and business side, we try to try to get as much data and get people use as much as possible. From personal perspective, we maybe have different viewpoints. So, but that's something to take into account. You cannot maybe use all the data. You cannot maybe store all the data. You cannot maybe, or if you can store it, maybe you cannot store it enough a long time that you want to. So how you can build the kind of processes around it to keep your models up to date all the time, and how you also find the reasons why you need that data, particularly working together with legal, maybe our privacy teams, to figure that out, why this data is needed.
This buy and build decision, like, did you have to decide either we buy or build? But I assume Veriff already had a bunch of in-house stuff, but...
Well, in this, like I mentioned, for buy and build, there are different options. I honestly think first always buy. If possible, buy. Like, because you have to figure out the concept at first. It's the same as those Indian guys in Amazon shop. Like, set up the shop, figure out with the Indians whether it overall works. Then, like, if it kind of works, then start building it really AI as an AI shop. And the same is with building stuff in-house. Building stuff in-house is really expensive and needs a lot of work. And like I mentioned, where you get the data, how you define that you need it, where do you get the labels, it all takes time. Then you need to train, then you need data scientists who are really training those. It's like big team and it's big time investment and it's really uncertain. It's like quite risky to build stuff in-house, I'd say. So maybe first buy as much as possible. Unfortunately, with buying, there's some limitations to what you can buy. There is kind of really standard things that you can buy, OCR services, segmentation services, classification services, all of them. But again, if you go into really specifics, then at some point you cannot buy because nobody's selling. Nobody's selling fake document detector. Nobody's selling that. This is why you have the companies who are building that. Again, if you talk about, I don't know, some LLMs that also you like this topic in a sense that general LLMs, yes, available. But if you want to have some LLM that is, or like chat with, really, really specific knowledge has about, I don't know.
Or as simple as how this specific company deals with refunds. So different companies have different refunds.
Exactly. Yes, exactly. So it's whether it's some really specific domain or it's really specific knowledge that it does not know per se. So then we need to start training. And that's again, the decision to make. In this concrete case that I brought up, there is no decision to make. Basically, in a sense that there is nothing in the field to buy. But overall, guys, fake it, buy it, and then start building it. Like, I think in a sense that the different complexity is so big, is so big, different. And I think this is something that if you really start building stuff in-house, is maybe hard to also explain to management or like to get resources for and so on, because it takes time. It's a research. It takes sometimes a year to build something that works, but it could be also that you put year work in and you figure out that, oh, that didn't work. Like that's one of the things that also comes up with kind of building those machine learning models yourself is in-house, is that you throw away the work a lot. Quite, I would say way more a lot than like in building software. You usually kind of know what you're doing.
That's that's one topic that I want to cover is like, how do you work with machine learning engineers, data scientists, etc. Because I talked to one from Zendesk, and he said that like with software engineering, it's easy. Like, okay, we need to build this internal tool. It's relatively easy. It requires API, database, server. I give it an estimate of 2 weeks because everyone knows how APIs work. And with AI, ML, whatever models, it's like, can you give me an estimate when you will build it? I don't know. I can build you something tomorrow, but it will have 80% right responses, or maybe 70. When
I think you would not even know.
Yeah, when will you reach 95? I don't know, maybe never. How do you even work with this?
Uncertainty. Yeah. I think there are, like, that's one of the things too, first knowledge, in a sense that there is way more uncertainty into building and doing research. This machine learning topic is a research topic, meaning that usually we are going into trying to solve something, but we don't know whether it's even solvable. And that's, there are a couple of things I have used myself. So to maybe manage it from the product's perspective is always kind of have different tracks in the teams, not have everybody doing huge research, but have some people doing kind of more researchy topics that maybe that might benefit and might not, but let's see. And you have other people or like other topics at the same time in parallel, which are more tangible. You still have some of the things, which are a little bit more sure because we have been doing it, or it's improving something, or it's adding more data, or it's like similar to something what we have been doing, or it's again, we play around deep learning, machine learning, and those simple algorithms. So simple algorithms are easier to do than the others. So you play around also with making sure that you always have something coming out from the team so that everybody's happy all the time. But at the same time, you sort of have some big topics going on. Another thing is regarding maybe time boxing those topics. So that that there is a problem. We don't know how to solve it. We have a couple of ideas. Let's try it a month and that's it. Like, let's just try it for a month. So at least if you waste time, you waste it for a month. Unfortunately, that with that tactic, it might be that the month plus 1 week would give us results. It always feels like that. I know data scientists I have no idea and want to still try it again. But that's where I've been trying to use it, in a sense that at least if we get a good idea, we usually get it quite fast, but it reduces the amount of time wasted. So yeah, that's something to take into account. And of course, with icing those projects, the kind of communication to stakeholders, again, to up about the expectations and so on, has to be really clear. So that is one thing to kind of always keep in mind, is that people are usually unhappy if they don't know what's happening and what is expected. So you have to always keep that in mind, that you educate the people around you about what you guys are doing, what is possible to estimate and what is not. Of course, we have our own hopes and everything like that, and we could have the goals, but we cannot have the goal for one project per se, because we don't know that if this project or method, how we are going is the right way to solve it.
Mm-hmm. Yeah. Just want to add one more thing. You mentioned like mix research and doing stuff that we already know.
Mm-hmm.
You also mentioned time box it to a month, let's say. Probably a third option could be buy versus build. Like,
well, yeah.
Again.
Like that is the more sure is buy.
Okay.
Usually, yeah.
You touched on probably one of the biggest topics, stakeholder management, or maybe expectation management, because many people think, how can we use AI for doing X? Or, for example, one of the topics for the future was, there was a CEO of Shopify, and I think now Duolingo as well, and maybe some more companies, I don't know. They were saying that now before hiring, go and check, is it possible to do with AI? Many people say we come into AI age, we need to do AI. Do you feel like there's a expectation of AI?
AI will solve everything?
No, yes, but in a sense, is it overhyped or is it moderately hyped? The expectation meets the reality, or something is still missing?
I think honestly, it depends probably on the companies and people you talk to now. I feel the biggest boom has now started to slow down, in a sense that people have started to realize that maybe it is for its own purposes why we use it, and it's for some of the things why I use it, and for some of the things it's really good tool. And our focus is a good tool. It's a tool, how you use. Then I have had similar discussions a couple of times with whether some other external companies or some people have thought again, like, hey, you have some knowledge how you should, we have this AI stuff, how we should now automate our work. And then I come back to again basics, in a sense like, yeah, cool, you want to use AI. But first is, what is the problem you want to solve? What is the problems that you have? Like, okay, because most people in reality, if you talk about AI today, maybe it's something to bring up here, is we have two topics with building AI products. Those are the companies who we talked about. They are like building the products themselves. That's core is AI. And like without it, it's like there is no product. If you're not doing that, then you're mostly doing automation with AI. You're automating something. And 9% of the stuff we do with AI today is in reality today automation of some our tasks, some other people's tasks, then it starts all with, what problems do you have? What you want to automate your time. Okay. Your tasks. What takes you the longest? What is the most routine? Like I think I talked to some people, it was even the solution could be like, just make it some automation in Jira. And ta-da! AI automation, but it's not like a machine learning awesome thing. So I think like that's again why we need to look into it as a tool. We do not have to use it everywhere. We could use it in a lot of cases. I think it's really a nice tool to use it. But in a lot of the cases, we can get away with some smaller automation, some rules. Then we can maybe do some classical machine learning, and then, or use some classical machine learning, and then we can use like some deep learning or models themselves. But we first need to start with analyzing what are the problems in reality you have, and what are the mundane stuff that's going on, which is taking long time or it's really repetitive.
Mm-hmm.
Mainly repetitive and taking long time. Process is the problem in a sense. That's the thing that you want to do. What is it? How it works? Can you split it? Do you have data? Like exactly the same thing goes there. So now we have reached from the sexy AI topic into really, really tangible everyday problem in reality that we need to solve.
Just to clarify, there was a CPO of OpenAI came to Lenny's podcast and Lenny's event, and he mentioned that AI changes everything. So, and every PM will have to learn how to write evals or something along the lines. I'm probably very bad at paraphrasing, but that's the gist that I got. Do you agree, disagree, or any thoughts?
I call it or think about it maybe a little bit with different word, and I mentioned it before. Like you should, as a product manager, understand what is the kind of right answer, what you are expecting, and what is the kind of wrong answer. So you need to have the understanding of that and kind of have mapping of it kind of somewhere. So yeah, I think like this is important. It's in a sense that you have this understanding. Your understanding can. What is expected, what is kind of not expected. If something is expected, what should do next. If something not expected is coming, what should you do then? Regarding writing those evils, myself, I think it's really maybe chatbot specific in a sense that you are writing some specific things that you're expecting there. I think it's kind of broader topic if it can't go out of language processing overall, that you should have the domain knowledge. And why you should have it in a sense is also to understand whether something starts to go off at some point. So one of the things with machine learnings is that you train it at some point. It has this knowledge, and it doesn't have new knowledge unless you retrain it at some point. So how you evaluate that now, for example, is the right time to retrain. How you again help to build those in reality systems or processes around it. So you need to take those things into account and evaluating, of course, your own kind of system, its performance. It's really important to understand that, because otherwise, again, you cannot build and design really nice product around it.
After this discussion, it seems like writing evals is about coming up what is the right answer, what's the wrong answer, figuring out what data we can have and what data we put in, what data we get out. But it's also, as we mentioned, it's very specific to domain. Probably in Veriff, it's about image. Like here's also it's imaged. Here's what it gives us the result. I don't know, probably some JSON or whatever. And we're checking if this JSON is exactly the right format as we expected. Does it have all the data that we expected, or does it give some gibberish? And
yeah, well, we expected the answer is right in a sense. Like we expect that if we are showing an image of a cat, then it says it's a cat, not that it is a bunny or dog or something. So that's basically the expectations there. And we expect probably that if it's for a chatbot, if you talk about, for example, customer support cases, you can describe some case there, and you expect that it is answering with some logic based on, in reality, the policies that we have teached or rules that we have teached it with. So you can write those things up, and similarly, you can basically test them like we have in software engineering unit tests. You can test them out.
Do you ever have any funny case where, let's say, that if you like the tool checks the ID and then it gives some weird information like, yes, we see there's a cat on the picture or something like this?
We haven't had, well, it depends how, again, you build the system. We didn't have a cat check per se. What we could have is like, we didn't see a face. And by the face, you mean human face, not a cat face. So again, really good specification or evaluation that by face you mean human face, not then some animal face, because face could be something else. Yeah. So like, there are always funny cases with, I think, machine learning happening. And I think if we every day use the chatbots that we have, then we can see also sometimes they are strange. They are, you mentioned also hallucinating, in a sense that they are creating some story up that is not in reality there and seems real, of course, then you need to evaluate whether it is real. But in some cases, you understand that it's kind of just silly. But yeah, I think there are always with all those machine learning things, the things that they are doing wrongly sometimes could be silly, sometimes are frustrating. But we have to take all of our job with the joke. So let's laugh about the mistakes they are doing.
Yep. I think I'm done with evals and the topic of like specifically building the product. I'm not sure if I will come back to building the product, but maybe there's something you wanted to mention that you think that we missed, or
I can make just a conclusion. So regarding building the products overall, I think is things to keep in mind. Like first is do simple stuff first, which is, if possible, rules, then machine learning, then deep learning. By, if possible, then and scope down the problem as much as possible. To smaller problem, you will get quicker results. Then again, doing in-house machine learning. One thing is it's expensive. There's people, different teams, different support, the processes that you at some point need to support this building and maintaining. You don't build it, you maintain it afterwards. It's like a kit. You will get a kit and it will, you need to all the time keep it up to date unless it's really some problem that never changes in the world. I don't know, like detect rectangle versus circle. Okay, that doesn't change. But mostly the world changes so around us. So we need to keep up to them. We're with them forever. And also the team that's there. If you start building also, you need to have really good stakeholder management to basically make sure that everybody understands it's research still if you're building something. And we don't know the results for sure. A lot of the times we know the results afterwards. This is something then to figure out how to manage, split into smaller pieces, time blocks, and so on. And then we talked about all the other aspects. But I think this is the conclusion about building.
It was a conclusion, but now I have a question about maintenance. If let's say if we split between like maintenance and actually building new stuff, new features, what do you think would be the split? Or are they like a split in how much time of your work, or maybe engineers' work, data scientists' work? How much is a maintenance and how much is actually building new stuff?
Well, if you talk about maintenance in reality, a lot of the times is adding new data or a little bit better data, maybe transforming the labels or the kind of said what is the right and wrong answer a little bit differently to make it better each time. But machine learning is iterative process, which means in reality, if you have a model, then usual in-house that you need to retrain, then usually come back to that problem every year or every 3 months, or depends on how quickly it changes. In Veriff, I think we did, over the 5 years I was there, we did, I think like for a lot of the bigger things, the core things, like 5 rounds. So first we did first round, we got to some results. We got better knowledge. We, the overall, the models got better over the years and so on. Research got more stronger. Then we did another one and we did another one. And basically in that sense, it's a lot of the times, you are with the same problems over the years. It's just that you are always doing this iteration.
It kind of, now it actually reminds me of, building something new is like shipping version 1 or I don't know, proof of concept, MVP, whatever. And then what we call maintenance is actually iterations of improvement.
It depends how you define the maintenance. But if I mean like maintaining it, making it better still is part of the also maintenance, then yes, a lot of the times in a sense that you are maintaining and improving it kind of the same time.
Okay. An example could be like, let's say Veriff. Let's imagine we are in Veriff and today we operate in Estonia and Latvia. tomorrow we launch in Lithuania, our model can really well identify Estonian document, Latvian document, but now we need to teach it to identify Lithuanian. It would be kind of like a maintenance.
Then I wouldn't put it as maintenance. It's something new, but rather let's also take a bold example on ETAs or how we calculate ETAs for taxis or something like that. Then we have a model today where there are some logic. There's some problem. We have a problem. That's basically better. We have a problem. We have solved it somehow. It, of course, everybody knows it has its good sides and downsides. It probably does some mistakes. But it's, and we know it's never perfect also. It's one thing, but you never know it's perfect. But what you can do is you can get better at it. So you have a first iteration, maybe you solve some other problems in real while, then you come back to it, you have more data, how it has performed. Maybe we have new cities also where it hasn't been working so well. Then you gather the data, you rethink maybe how you solve it, and then you redo it. But it's kind of this maintenance / improving it part also. So probably if you wouldn't come back to solving the same problem again, then you wouldn't, the overall performance would go down also probably. You need to keep it up to date with the new data.
Mm-hmm. Thank you for all this. Now the most important question for everyone listening, most important stuff in the world, how to actually become an AI PM.
I think overall, first is start getting into PM kind of overall role. And I think a lot of the skills that we look at AI PM are in reality regular PM. But like I mentioned, that AI has some specific, I see it's like specialization into some of the things. So what are the things you need to understand more if you want to focus on AI products? I think it's really, as everything around there is about data and in reality statistics, then it would be good if you have a good gut feeling about the metrics overall, that you understand how to use the metrics, how to measure the product success, and are have a gut. I would say at some point you need to have kind of good gut feelings about what makes sense and what not. It comes with the time. Secondly is, of course, good is if you understand the basic principles about the different AI machine learning algorithmic methods to some extent. You don't need to be able to build them, but I think having understanding how overall the machines think, how they work, how they're trained is good, because you are working together with data scientists or the machine learning engineers who are doing it every day. You need to speak the same language. It's really hard for them to explain to you what's going on, and it's for you to explain to them how to build the stuff or how you can help your team if you don't speak the same language. So understanding the basic kind of principles about how this is done. What are the steps to build the machine learning stuff? How you evaluate machine learning models? You don't have to know all the statistics behind the machine learning model and how they work. I think a lot of the data scientists themselves do not know about all of it and how in reality everything works. Because in reality everything is statistics. If you talk about in reality, all of this is statistics. We're statistically estimating something like this is how it should be. But I think what are the basic knowledge is understanding the kind of types of machine learning models that there are, what kind of problems they are solving, what kind of use cases they are for. Then basic understanding about, I mentioned confusion matrix. What is confusion matrix? What it is? What is precision? What is accuracy? What is recall? Understanding what they are. Not reading Wikipedia, but really understanding what they mean, in a sense that how in reality you would use them in business problems then if they come in. So I think this is the kind of level I would go to. creating your own machine learning model, I think it's for product manager. Maybe you don't have to know, but it would be nice that you maybe build your own really, really simple one. Like doing a really, really simple one in Google Colab is really easy. We have been doing it in uni, where I have been giving the AI product management course. It's just like collect some random data from internet that you can, then just put it in, then see how you train it. What are the steps? You have to just see what's the steps. And I think that's the enough knowledge at first to kind of understand what's going on. I think you don't have to have like huge statistical background to understand everything in a sense, and you don't really need to be so kind of hands-on that you know all the research papers and everything like that.
And you mentioned that you're also teaching at university one course or maybe a program on something about AI product management. Like, what do you teach there, or what did you teach there?
So yeah, I've been teaching AI product management. I've been teaching it one of other person also. So what we are talking about there is that what to overall take into account when building more on the AI products in-house and the machine learning models in-house. Why we started with it is we saw that there are a lot of misunderstandings how easy it is and what it really means. So that's why we started the kind of course, to get better knowledge to people and educate people around this topic. So we cover the same things that we covered here a lot of the times, but now more in depth into practical things of how are the different ways how you can solve AI products, what are the different methods, machine learning models, or what do you use, how you gather the data to yourself, how you define the problems in a better way, the legal aspects, about the team aspects, what are the team and team that you need in reality, and yeah, so kind of a lot of those topics in reality we cover there that kind of give you brief understanding about how to build in-house the AI products.
Mm-hmm. And do those certifications, courses, do they really help with, like, I don't know if you have experience with hiring for AI PM roles specifically. Like, what are you looking in the candidate?
So when I have been trying to find PMs for those kind of AI product manager roles or teams working really, really closely with this data scientist teams, then first I'm looking whether you already have experience. Another thing is a lot of those people have analytics or data science background themselves or something like that. So they're coming from that world because PMs come also from multiple worlds, but one of the worlds you could come is analytics. And in reality, also like really quick learners, just people you see that want to learn about the new domain and are eager to understand that, because that's kind of what is also always the path forward is you learning it and understanding that maybe everything that was in your first playbook does not work there. That when you work with data science teams again, then the classical sprints that maybe everybody's used to working do not work really well. So you need to change your playbook and figure out what in reality works.
Mm-hmm. There are probably many PMs who want to pivot to AI. Maybe first question, should they? Does it make sense for many PMs to pivot?
I think this knowledge about machine learning and AI will more and more become the kind of standard knowledge for all the PMs. Maybe they do not know everything so in depth, but they more and more start kind of hearing it because they start using it. They gather the knowledge overall. So a lot of this, I think, that we have been talking today will slowly become part of this kind of classical kind of PM knowledge base. But we still will have, I think, some kind of specializations or topics that we are more passionate about. I think this will remain in the sense that there are, again, more people who overall probably will look into that and focus on there. And there will be other people who are less focused on this topic and have less knowledge about how to deal with those products.
Yep.
Yeah. But yeah, as AI is growing and usage of this is improving, then I think there will be more and more people who need to have the understanding how to build those products.
And thank you. Do you have any final thoughts or maybe practical advice you'd like to share with aspiring PMs or PMs who want to become AI product managers?
I think get your hands dirty with the first thing. I think it's appreciate trying and failure. I think it's the best thing to do. Have the mindset that everything that maybe you have kind of tried before with product management, and now you have the statistical product do not work. And I had one thought. Yeah, and again, let's start first from the problem. Don't think that there is some new thing that is so exciting and you have to use it because of that. You use it when you think it fixes the problem, but start with the problem. And from there, you start figuring out what you should be using.
Thank you very much, Liisi, for all your answers. It was very insightful. Where can people reach out to you?
Well, I'm LinkedIn. If you write to me LinkedIn, I'm there. You can reach out. My name is Liisi German, so reach out there.
Thank you.
Thanks, Nikolai.